Hello everyone, welcome back to my YouTube channel. It's been a long time. This is Hemashri, studying in Sri Venkateshwara College of Engineering, currently pursuing my second year BE in Electronics and Communication. Today in this video, I'll be talking about memory hierarchy and I'll be taking cache, RAM, secondary storage as my topics, and this comes under the subject computer organization and architecture. So let's begin with the video. So let us begin with introduction. So let us know about the definition, purpose and importance of memory hierarchy. So coming to the definition, it is an organized structure of storage devices in a computer arranged by speed, cost and capacity. It ensures efficient data access by storing frequently used data in faster memory levels. So let us know about purpose. Its purpose is to bridge the speed gap between the CPU and slower storage, ensuring optimal data transfer and reducing wait times. So, the importance of this memory hierarchy in computer architecture is it enhances performance by allowing quick access to frequently used data, balances cost and efficiency with a mix of fast, small, and expensive, and slower, larger, and cheaper memory. So let's go to the next slide. So next, let us talk about cache memory. Cache memory is a small high-speed memory located closer to or within the CPU. It stores frequently accessed data and instructions, reducing the time it takes for the CPU to retrieve this information from the slower main memory, that is RAM. Cache acts as a buffer between the CPU and RAM, improving system performance. So there are three levels of cache. So level 1 cache, it is closest to the CPU core, directly integrated into it, and it is smallest in size and fastest cache but limited capacity. The second level cache is slightly farther from the CPU, more than L1, that is level 1 cache, and it has a larger size, um, to about 1 MB. It is slower than level 1 cache but still much faster than the RAM. Cache, level 3 cache, it is shared among multiple CPU cores, largest size up to several MB you can tell, but it is slowest of the three levels but still faster than the RAM. So now let us know about the few advantages and disadvantages of cache memory. So coming to advantages, it has high speed and it improves the CPU efficiency. When in case of disadvantages, it has a limited capacity compared to RAM and secondary storage. And due to its high speed and design, cache memory is more expensive than RAM and secondary storage. Now let us know about how cache works with the CPU. When the CPU needs data, it first checks the cache. If the data is found, the CPU retrieves it quickly. If the data is not in the cache, then the CPU fetches it from the slower RAM and sometimes from secondary storage, which takes more time. Once fetched from RAM or storage, the data may be stored in cache or for future use, reducing the time for future access. Cache memory plays a critical role in speeding up CPU operations by minimizing delays in data access, enhancing overall system performance. Now let us know about RAM. So RAM is a fast volatile memory that temporarily stores data and instructions needed by the CPU during operation. It provides quick access to active programs but loses data when powered off. There are two types of RAM, that is dynamic RAM and static RAM. So dynamic RAM, it is commonly used slower, it needs refreshing, large, it has a large capacity and cheaper. Whereas in static RAM, it is faster, there is no need of refreshing, it is used in cache, it has smaller capacity but more expensive. So when it comes to advantages, RAM is faster than secondary storage and it has a direct access to data for quick processing. So while coming to disadvantages, it is volatile, that is when meaning is data is lost when the system is turned off, and it has a smaller capacity than secondary storage. A role in memory hierarchy, it has some role in memory hierarchy. So RAM sits between cache and secondary storage, providing fast access to the data and CPU needs, while storing more data than cache but less than secondary storage. So let's move on. So next is secondary storage. Secondary storage is non-volatile memory used for long-term data storage. It retains data even when the computer is powered off. So examples are hard disk drive, solid state drive, and CDs, DVDs, etc. So advantages are it has a high storage capacity and persistent storage for files. There is a persistent storage, and it has applications and backups. Disadvantages are it has a slower access speed compared to cache and RAM, and its mechanical components can wear out over time. So its uses in computer systems are storing the operating system, applications, and large files. It is used to backup and archival of important data, and it is used in booting the system from secondary storage. So now here is a table which I have made with the respect where you can compare cache RAM and secondary storage with regard to each different aspects. So I hope this would be useful for you. So moving on. So here is how memory hierarchy works together. So data movement between cache, RAM, and secondary storage. So CPU to cache. The CPU first checks the cache for data. If it's there, the CPU quickly retrieves it. From cache to RAM. If the data is not in the cache, it's fetched from RAM, which is slower but holds more data, and then it is from RAM to secondary storage. If the data isn't in RAM, it is retrieved from secondary storage, which is the slowest but has the largest capacity. So second thing is it has access and time. It has access time and efficiency. Then cache is fastest but has limited capacity. RAM is slower than cache but can store more active data. Secondary storage is the slowest, but it is used for large storing capacity and less frequently accessed data. So this hierarchical flow optimizes speed and efficiency by keeping the most frequently accessed data. So in conclusion, memory hierarchy optimizes computer performance by balancing speed, cost, and capacity. It ensures fast access to frequently used data, while larger, less frequently accessed data is stored in slower, cheaper memory, and this structure improves efficiency, reduces data retrieval times, and enhances overall system performance. So I hereby conclude this video. Hope you guys understood it. So thank you. Please don't forget to like, share, and subscribe.